Dunque, dove mi metto io? E il computer?
Ci sono le prese la seconda per collegarlo, la presentazione
Sì, ma chi le cambia le slide?
le cambio io, che sono
Faccio un cenno allora.
esatto, vedrà le slide là sopra, se no c'era un telecomando fantastico.
Sì. Ok, cominciamo. Ok, good morning to everybody. Buongiorno a tutti gli italiani. Buenos días a los españoles y que calimera se hola ma potinellava. I am Francesco Papucci from Port Authority of Livorno. I'm in charge of developing innovation and technology projects. And the title of this lecture is referred to a 10T project called Green Cranes. As we can see later in greater detail, Green Cranes is a project focused on developing solutions for reducing the environmental impact of port operations through the use of alternative fuels and the adoption of IT solutions. But I would not limit my lecture only to that topic. I would rather use the Green Crane project in order to giving you a sort of vision of the existing links between port operations and the opportunities offered by the energy sector and specifically the gas sector for strengthening the port development. Well, the first part of my presentation is intended for presenting you the Port of Livorno, not only in terms of seaport, but also for summarizing its operational capabilities in terms of integrated transport and logistic platform, and showing you the main infrastructure, the services, the assets, and the main development projects, while the other part of the presentation will focus on the Green Cranes project and more in general in the energy and the gas sector. Well, let's start having a look of the geographical location of the Livorno port, as you can see in the slide, and its integration in the European transport network. As you surely know, Livorno port has been inserted in the European core network as gateway port for accessing the strategic corridor number 1 through the high-capacity, high-speed Florence node. In this sense, the Livorno logistic platform is serving the main existing routes from or to Far East and from to the American continent, acting as gateway for multimodal transport operation. Moreover, as far as short sea shipping is concerned, Livorno is currently playing also an important role in the motorways of the sea system, providing connections between the main ports operating in the Mediterranean basin, both on western and the eastern side. As you can see in this picture, the Livorno platform is completely integrated with the global transport network, acting as multimodal gateway for its referring markets. In addition to the traditional, for Livorno, traditional routes that have always characterized the port of Livorno as the Atlantic ones towards North and South America and North and South Africa, the Livorno system is also strictly linked with Far East and East and Far East routes, offering connection with China and the major Far East ports, Red Sea, East Africa, Arabic Gulf on almost daily basis. Moreover, as important note of the motorways of the sea system, Livorno also offers daily or weekly links with the major Mediterranean ports in Spain, France, Morocco, Algeria, Tunisia, Egypt, and Turkey. This wide range of maritime routes is then linked with the northern, central, and eastern Europe markets, thanks to the European corridors integration of the existing local logistic chain and multimodal facility. So speaking about infrastructure availability, the Livorno logistic platform can offer a wide range of facilities for handling different kind of goods, dealing with different transport modes. Just to give you some relevant figures, Livorno is a multi-purpose port in which are handled 30 million tons of goods, 650,000 TEUs in terms of containers, and over than 3 million passengers every year. These results have been achieved thanks to the following infrastructure availability, such as a passenger port, a commercial multi-purpose port, an industrial area, an inland port, and a dry port. All of them are fully integrated, both on the infrastructural and the infrastructural or IT services point of view. Well, let's now have a photographical survey of the above-mentioned infrastructures, going from the southern part, the nearest to the city center, mainly dedicated for passenger and leisure, to the northern part, where are located the commercial and industrial facilities. In this picture, you can see the shipyard and ship repairs facilities. The former shipyard that was in this area went out of business 10 years ago. After an intense industrial requalifying and urban restructuring project, now this area can count on facility for the building of large luxury motor yachts, up to 70 meters long, while on the other side, parts of the old shipyards areas have been dismantled, requalified, and given back to the city for public use, and now contains the infrastructure needed for running a leisure port. The whole area covers a total of 500,000 square meters, on which we can find a large motor yachts construction unit equipped with docks for both production and repairs, an area of dry docks for larger ships maintenance and repair, that is the only former activity that remains, a yacht service center, a leisure port located inside the historical so-called Molo Mediceo area, and an extensive residential area connected to the heart of the city. The second picture is referred to passengers. Passengers have always been a strategic factor for the Livorno port, especially due to its ferry connection with Sardinia and Corsica, which totalizes more than 2 million passengers per year. Cruises is another relevant business that has significantly grown over the last 10 years, reaching a total of more than 400 ships arrival and 1 million passengers per year, achieving in 2011 a growth of plus 19%. Moreover, Livorno is today the home port of important cruise lines. In order to strengthen passenger devised services, many investments have been made in the recent past, and many are currently in progress in terms of waterfront requalification, safety-oriented services, and development of IT and wireless application for passengers and tourists. In this picture, you can see the areas divided to the Ro-Ro and Ro-Ro PAX operations, in which Livorno is nowadays one of the Italian major ports. I suppose that all of you are familiar with terms of RoRo, PAX, and well, in general with the port-related terminology. RoRo and RoRo PAX national and European cabotage are certainly one of the most important keys that are strengthening the role of Livorno in the as gateway port and in the motorways of the sea. Referring to 2011, the total RoRo traffic totalizes 330,000 units and a significant total of 13.5 million tons of goods. In this picture, you can see the main container terminal of the port of Livorno. The terminal Darsena Toscana that can handle up to 800,000 TEUs per year. Statistics for 2011 are quoted about around 640,000 TEUs and a total of 8 million tons of goods. Well, the terminal is equipped with 1.5 kilometers of quays, 8 portiner cranes, 8 truss-tiner cranes, 22 reach stakers, and a large fleet of handling vehicles. It has a railway terminal and also a reefer area. The terminal complies also with the most recent regulation in terms of ISPS code and quality and environmental regulation. Moreover, as we can see later in detail, the new Livorno Port Master Plan foresees relevant investment in the container terminal sector, especially in terms of expansions of the total surface area through the completion of the dredged material basin, containment basin. In this picture, you can see both the reefer terminal and the dry bulk facility. As said before, multipurpose has always characterized the vocation of the Livorno port, and today new important opportunities are growing in the sector of fresh and frozen goods. I mean forestry, bulks and dry bulks, paper, new cars, project cargo and components. Some figures, 2.7 million tons in the general cargo segment, fresh and frozen goods, forestry and paper, 1.2 million tons in the dry bulk segment, metals, minerals and grains, and 8.6 million tons in the liquid bulk segment. This will offer also new opportunities for development of new integrated logistics services between the port and the city. For instance, the reefer terminal started its activities in September 2011, so not time ago. And here you can see a global aerial vision of the industrial area. Livorno hosts the second gas facility in Europe and also offers refineries, oil stock areas, energy power station, and important chemical and automotive groups that are operating in this area. Furthermore, from 2015 onwards, Livorno will host one of the 3 offshore LNG plants foreseen in the National Energy Plan. So, Livorno is part of the Northern Tyrrhenian Port Cluster, together with Spezia, Genova, and Savona, a cluster which is integrated with the Trans-European Network Transport Corridor number 1 and 24. In particular, through the high-capacity and high-speed node of Florence, the Livorno platform is fully integrated in corridor number 1. But unlike other northwest Tyrrhenian ports, the Livorno zone can count on favorable conditions for its future development, as there are no special constraints like hills or mountains, general good weather condition, and no densely inhabited areas around the port zone. Well, considering also the good level of road and rail connection existing between the various parts of the port system, for instance, motorways and rails ends directly inside the port terminals, all these facts are making the Livorno considered as a global platform a suitable place for logistic operations and also for strengthening its future growth potentialities. In terms of integration, for instance, the inland port of Vespucci is located 4 kilometers away from the port of Livorno and has a direct road and rail connection with the port. the inland port, or better said, the freight village, has a total surface of 2.8 million square meters, a cargo consolidation with multimodal access, both boat and rail, a distribution center, packing firms, custom clearance, that is important, and scanning areas, and a railway terminal. As we can see later, many efforts and investments have been made for reaching a full integration between port and inland areas through the structuring of a secure corridor using ICT technologies, and more specifically RFID tags. In particular, 10T projects have offered us the possibility to develop, test and deploy the RFID technologies for setting up secure corridors and allow gate access, automation, and seal checks. Another infrastructure that you can see in this picture is the dry port called Il Faldo, an area devised for new cars stocking and distribution. Il Faldo has a total surface of 640,000 square meters, a maximum capacity of 25,000 cars, and it has road and rail accesses, and it is fully automatized. In 2011, this kind of traffic has reached 470,000 units, with a growth of 10% compared with the previous year's results. The main development project, the new port master plan foresees important investments for improving the overall performance of the Livorno logistic platform. The new port master plan is based on three main axes. The first and most important is the optimization of the current port zoning policy through reorganizing functional areas and homogeneous services, as for instance, setting up a new pole devised to Ro-Ro, a container pole, and fresh and frozen good pole, so dividing a better organization of the port zoning. The second is improving railway infrastructure and services, and a gradual extension of the container terminal areas, as you can see in the picture in red. In orange, are focused the development areas for the container terminal, mainly through the use of dredged material basin. And the third point of the port master plan is the development of high added value services in the ICT sector for a better integration of the port community, whole port community. In these slides, you can see a global vision of the transport chain and how the various elements that are part of the Livorno platform are integrated. Here you can see clearly where the various facilities are located. In particular, you can see the seaport on the seaside, and the inland port 4 kilometers away, and in the middle the town. And it has to say that integration is one of the most important aspects of the future development port development plan, because today the integration between ports and inland ports, and more in general the integration of the ports with the logistic structures behind the port, is the real key success element for the port development. Well, let's now have a look of the general policies adopted by the Port Authority of Livorno in its port master plan, in order to ensure a coherent framework for sustainability and eco-efficiency in the port development. As we can see later in details, the strategic vision of the extended green port is a sort of vision of the future in the sense that it is actually inspiring most of the action carried out in our port, including our participation to relevant European level projects. The key element of that policy is combining or trying to combine better efficiency and environmental sustainability at the same time. Well, we could say that this could be a possible definition for the word eco-efficiency. Well, Extended Green Port is the Livorno Port Authority's strategic vision for achieving eco-efficiency during the implementation of all the port development actions. Why extended? Extended means that both the design and the realization phases of such actions have to be inspired to by the Green Port policy framework, not only as far as the port is concerned, but also taking into consideration port interland, logistics systems, and surrounding territories. The Extended Green Port policy has 7 main axes: environment, energy and resources, infrastructure and services, integration with surrounding territories, well, financial issues, and port traffic management. In particular, through this picture, we can better understand which are actually the most relevant statements that are setting up one of the Extended Green Port key pillars. As you can see, we are talking about environment, energy and resources, infrastructure and integration, knowledge and port traffic management in terms of effective policies that have to be implemented in each action that we make. It's important to note that each one of these statements plays a role, smaller or greater, in contributing to reaching the final objective of eco-efficiency. For instance, in the energy sector, as you can see in the frame, the decision of favoring the creation of energy districts aimed at supporting a widespread use of renewable sources, or in another sector, in the services and port traffic management, the decision of implementing the European maritime directive through the development of telematic services or improved communication between port actors, port community system, and so forth, well, are all decisions that allow us to go a step ahead in the direction of having a greener and smarter port environment. In this picture, even if it's quite complicated, I would like to show you some example of how the Extended Green Port framework policy has a direct impact on actual actions carried out by the Livorno Port Authority. For instance, the policies described in the infrastructure, port innovation and maritime traffic management seen before to protocol with the Italian Ministry of Infrastructure in the sector of innovation and IT services, or as in the case of the policies described in the territorial integration axis that have driven us to deploy a strong cooperation with the Tuscan region and more in general with the Italian government for acting at European level in view of structuring a multimodal short sea shipping Mediterranean corridor with Romania and Bulgaria, for instance. Or in the case of our participation in projects like Green Cranes or Most for Most or other that are fully compliant with our strategies in terms of environment, energy resources, and innovation. Okay. Well, let's now have a look to a more detailed look about the Green Cranes project. The Green Cranes project. Okay. Well, Green Cranes is a 10T co-financed project, as the train modes that are hosting this course, and has been applied in the 10T annual call 2011, and Well, it means green technologies and eco-efficient alternative for cranes and operation at port container terminals. That it means that the project is specifically intended to analyzes specific aspect of port container terminals. Port container are part of the ports of a port system, but not the only part. Of course, we have other kind of terminals, and each one has its own characteristic. But in any case, the Green Cranes project focuses its attention to the port container terminals, and it takes the form of a pilot actions, which involves 3 member states, Spain, Italy, and Slovenia, and joining public administration, important strategic ports, and port industrial partners, and innovation centers. Here you can see the Green Cranes consortium that is made up Valencia Port Foundation, that is the project leader, the Italian Ministry of Infrastructure and Transport that is acting through its implementing bodies that are RINA, Port Authority of Livorno, Global Service that is a private company operating in the crane sector, the crane maintenance sector, and Scuola Superiore Sant'Anna, the TESIP and Perceptual Robotics Laboratory from the Italian part. And then we have the Port Authority of Valencia, No Atom Port, that is an important chain, terminal container chain in Spain, and the Port of Koper in Slovenia, and 2 important industrial partners that are Kone Cranes Spain and ABB, that are two relevant companies in the port operation sector. Well, as everybody knows, freight transport and its associated logistic infrastructure are essential to keep the European Union in a leading position in the world developed areas, and we have to find some motivation that have driven us to present a project like Green Cranes. And well, a European document, the European Freight Transport Agenda and the European Port Policy in October 2007 pointed out some facts and challenges that have to be addressed in order to proceed in the way of the transport sector development. In particular, as you can see in the slide, congestion in some part of the European transport system is negatively affecting cost and time of transport. And also we have the need to address Europeans, well, worldwide level climate change. We have to reduce possibly our dependencies from fossil fuels, and we have to favor in every sector technological changes, and we have to try to reduce the emission of greenhouse gases. And well, we have also a strong need in order to harmonize regulations, communication, information flow between different ports, and more in general different logistic structures in Europe. So these are the general framework that has motivated the presentation of the project. Well, Green Cranes general goals and specific objective. Green Cranes aims at studying and defining methods and measures for describing port container terminals' energy profiles, for analyzing different technologies in terms of reduction of greenhouse gases emissions, but at the same time taking into account the competitiveness and the productivity. So the challenge is to develop technologies that will be able to increase productivity and at the same time decrease emissions level. And also to define standards or possible standards in order to supporting the swift investment in these technologies across Europe. Specific objectives of the project are a mapping of the energy profile in the participating port, an assessment of the technological and organizational process and improvement opportunities in the stakeholders' ports, definition of eco-efficiency of a set of eco-efficiency indicator systems that could be useful in order to plan and to carry out some policies for strengthening for enhancing the environmental impact, and finally to test prototypes and to deploy pilots in order to demonstrate the viability of the proposed alternatives, low carbon emission alternatives. And finally, the definition of possible standards and policies based on the project results to ensure the adoption of these technologies by a critical, we hope, critical mass of port container terminals in Europe. The project is organized in actions or activity. They are 3 activity, the 1, 2, and the 3. The activity 1 is focused on mapping port container terminals energy profile. The main objective of this activity is to describe energy efficiency and GHG emission profiles into the general model which describe port container terminal processes. In this activity, specific methodologies for the carbon footprint evaluation and equipment energy performance will be developed as a previous step for the evaluation of the alternatives. The activity 2 is exactly the evaluation of eco-efficient alternatives. In this activity will be developed integral evaluations with the aim of adapting existing solutions based on innovative low carbon emissions technologies and alternative fuels for port container terminals, equipment and handling machinery. The adoption of these technologies would significantly reduce the global carbon footprint and of port container installations. You can see in the picture an example of that alternative or potential alternative. For instance, the electrification of RTG. Well, we may see later a brief description of each port machine or port vehicle or port equipment. RTG are big cranes that are used in order to translate containers from a part of the container terminal to another part. Normally, RTGs are fueled with diesel. They are moved by diesel engines, and this kind of engines is producing a huge quantity of emissions. So one of the potential or one alternatives we have to study on it is the electrification of RTGs that may result in a lower emission level for that kind of operation. Other initiatives that we are developing in the Green Cranes project will be the adaptation of rich stakers. Rich stakers are other vehicles used in the port container terminals to be powered with eco fuels. The application of flywheel technologies to RTGs. Flywheel are technologies are the technologies used when you use the brake in, for instance, in your car. The energy produced during braking is then recovered and used after. So another idea is to try to recover a part of the energy spent during the translation and the lifting of containers in order to reuse it later. It's another alternative in order to reduce the emission level. And also the implementation of energy management systems, because knowledge is an important element for reducing emissions, because especially in an industrial environment, I cannot reduce anything if I don't know where I have to fine-tune my work organization. So real-time monitoring systems are very important in order to gathering sufficient information in order to reduce emissions. The activity 3, well, another part of the activity 2 is the evaluation, is the setting up of eco-efficiency indicator system that will be the instrument to address impact on the general operational efficiency of port container terminal processes. The eco-efficient indicators will combine pure performance cost indicators with energy efficiency indicators in order to produce a sort of environmental indicator. Well, the fact is we have to combine port process analysis with sort of consumption analysis. So the idea is to structuring a set of indicators in order to to take into account both aspects in order to produce some results in terms of environmental impact, or measuring environmental impact, better said. And the activity 3, the activity 3 is the part of the project devised to produce pilots, to experiment pilots. And 3 pilots are foreseen in the Green Crane project, where 1 for each port participating in the project. So 1 in Livorno, 1 in Valencia, and 1 in the port of Koper. Regarding the pilot in the port of Valencia, the first pilot will be based on the evaluation of both LNG and diesel Tier 4 fuel alternatives for PCT yard equipment. So one more time, we have to study possible alternatives, because we have the possibility to install LNG motors or engines, or to readapt the equipments to a greener form of diesel as the Tier 4. The pilot will consider the adaptation of existing machinery to allow the supply of LNG and to compare them with the last generation of fuel diesels as an alternative to the current diesel-powered yard machinery. The pilot phases will be substantially 4. The first phase is the evaluation of the existing, of course, machinery for the adaptation of to LNG supply. The second is the adaptation of diesel yard truck to LNG supply requirements. The third is the study of the investment return and environmental impact, and possibly the use of this pilot as a sort of tool or experience for orientating for future decision-making policies. Always in the port of Valencia, we have to say that this kind of experiment could imply an irrelevant amount of investments. As you can see in the slide, we are talking about 600,000 euros in order to readapt a fleet of 30 yard trucks to LNG. So it's a relevant investment for a private company in order to assure an acceptable payback. well, makes necessary the previous climate action based on the LNG supply using track and a cryogenic tanker of LNG. In this manner, I'm sorry, I forgot to silence. In this manner, the supply of the PCT equipment could be developed in order to test whether the energy consumption savings derived from the use of LNG could provide an acceptable payback for a full LNG installation. That demonstrate the feasibility of LNG supply installation for PCT yards equipment. As you can see in the table, you can see a comparison between the costs between two types of diesel and the possibility of using LNG as fuel. As you can see, it could be LNG could be an interesting alternative, but the pilot is important to test the viability of such alternative because it seems to be promising, but we have to test if it can be used in an effective way. So a pilot phase is really important for pointing out some important figures in this sense. The port of Koper in Slovenia, the second pilot will be based on the implementation of real-time energy monitoring system, which will be able to control energy consumption associated to port container operations. And this could allow stakeholders, not only the Slovenian terminal, but also at the other ports, to better evaluate the impact of such operation from the point of view of eco-efficiency and GHG emissions. So it's important also to develop IT systems in order to monitor what's happening in a terminal during the port operations. The pilot phases in the case of the Port of Koper will be the identification of energy cost center. In other words, department areas, units of equipments, and well, all the parts that are composing the terminal. The definition and the designing of the IT support tool. And finally, the measurement and the measurement activity and the data analysis of results. These are the three parts foreseen for the development of the pilot in Koper. And as far as the Port of Livorno is referred, the third pilot and demonstration will be based on the adaptation of a rich stacker vehicle to different motorization for reducing the environmental impact and also the energy consumption. Here you can see what is a rich stacker is mainly a forklift with a modified arm in order to lift heavy containers. It is used mainly in terminal containers for horizontal translation of containers in the yard or in the storage area. It is a vehicle mostly used in container terminal and heavily used in such terminals. So trying to change the motorization using alternative fuels, probably LNG, but we are studying on it at the moment, could result in a sensible reduction of the overall greenhouse gases emission of the port container terminal. So the first phase, of course, is the design of a risk taker that adopts alternative environmental compatible fueling. Why the design? Because normally you have to find the place to install the gas tanks, because these are vehicles projected to be fueled with diesel, and they have, of course, diesel tanks installed on board. But in case of gas or hydrogen cells or other alternatives fuels, you have to modify the structure of the vehicle in order to have the possibility to install additional tanks. And the second phase is the integration and the realization of a prototype according to the design phase. Of course, the third phase is the functional testing of the prototype and the pilot of the prototype and the analysis of the performance in a real working environment. So to use the prototype in line, not offline. So in the process. The expected results of the Green Crane project are, first of all, to test and pilot the solution, and hopefully that this pilot can really work and address the motivation we made. The second is to provide some policies for the European Commission in order to develop future general policies to extend the experience, if successful, of course, to other ports. So in this sense, we can say that expected results are for how can I say, for a political level on the one hand, and in a technical level on the second. Well, as I said before, Green Cranes is a relatively young project, having started these activities a few months ago. But so most of the technical development are under the work in progress status. But our first important results have been produced and presented, and I think that it could be important to spend some slides for showing the main conclusion of that first phase of the project. I'm talking about the port energy profile of the ports of Livorno, Valencia, and Koper. The port energy profile is activity made up of two sub-activities. The first, the characterization of PCTs, processes, and activities. In other words, sub-activity one was focused on analyzing the real process, the real working process or working cycle in a port container terminal. Trying to characterize different stages of operations, the relationships among the various operations and the vehicles used, and so on. The second activity, the second part of the first activity was the definition of the energy consumption map, and so according with the processes described in the previous sub-activity, in the second phase we have developed methods to describe energy profiles on footprint impact. And we've made a sort of energy consumption map. Well, the final objective is to set a sort of harmonized parameters, because it's important to to remember that we are operating on 3 different ports, 3 different terminals. So we had to face with different ways to measure consumptions, to describe the work processes, and so on. So sort of harmonization have been very useful in order to compare information and data from one port to another. Yeah. Well, how we made this analysis? In order to perform port container terminal energy profiling report, the first thing to do is to proceed with a sort of in-depth process analysis that can allow precise definition of terminals subsystems and the individuation of technical and human resources involved in each type of operation. Then, in the second moment, each element involved in a certain operation is analyzed in terms of energy consumptions, both fuel and electricity, in order to acquire information needed for estimating the environmental impact of such operation. And as you can see in the slide, typical port container terminal can be divided in 4 subsystems. The first, most important, we can say, is the loading unloading subsystem, and the yard subsystem. Well, the loading unloading subsystem is the part of the terminal where containers are loaded in a ship or unloaded from a ship. So is the main interface between sea and land. The yard subsystem is the place where containers are stored, temporarily stored, in order to be exported or imported. And the third subsystem of a terminal is the horizontal transport subsystem that allows transfer of a container from the gate to the storage area. And the fourth one is the delivery or reception. It depends on what sense you are looking at the process. Subsystem. I guess the part of the terminal where containers are entering or exiting. Well, in effect, typical operation in container terminal can be divided in 3 categories: import operation, export operation, and transshipment. Transshipment are operation made with the container remaining in the terminal in order to be transferred from a ship to another ship. So it's a sort of internal operation that not involves external subjects. Well, here you can see the typical vehicles used in a port container terminal. So the most important, of course, is the ship-to-shore gantry crane, indicated in the picture number 1. That is the main tool, the main equipment used in a port container terminal, as you can see just looking outside the window. The second is the RTG, the rubber-tired gantry crane, that is used in the temporary storage area, where containers are stacked and stored one above the other, in order to be transferred on the ship or to be transferred to the gate subsystems. And the interface between the quay as the zone where ship-to-shore crane are located and the yard is the vehicle number 5, the terminal tractor, that is quite important in the economy of a port container terminal, because it's a sort of shuttle continuing running from the quays to the yard, from the yard to the quays, in a sort of perpetual movement for translating containers under the crane in order to be loaded on the ship, or for transferring the containers to the unloaded from the ship and transferring them to the yard. So it's a sort of shuttle. And the vehicles number 3 and 4, the straddle carrier and the reach taker, that are vehicles to perform horizontal movements or vertical also movements, in order to rearrange the layout of the container storage in order to optimize future loading or unloading operation. Well, I mean, in order to optimize future loading in terms of positioning the containers in the right position to be loaded fastly, and in the other sense, to position in the storage area containers in the right position in order to be exited quickly. And reach takers and straddle carriers are the vehicles used for these operations. Here you can see typical. I'm sorry for the dimension of the font, but the idea was to leave you some more detailed information for future purposes. I mean, just to point out some elements in the diagram about the export process. As you can see, having divided the terminal in subsystem is easier to define movements, and so to try to analyze the energy consumption. Because, for instance, in a generic export process, containers arriving at the gate terminal, containers are arriving at the gate terminal, and well, no, not important. At the gate terminal, and they can arrive both by truck or by train. So in case they arrive by train, the diagram is slightly different, to tell you the truth. But in the case of truck, containers are arriving in the terminal, past the gate, and then we can have 3 different cases. Depending on the weight of the container is translated to the yard or the housekeeping area using a RTG or a reach taker or a forklift. So the use of the vehicle is depending on the total on the gross weight of the container, because an empty container is unuseful to move an empty container with a reach taker or a RTG, because they are a vehicle with a higher level of consumption, and is completely unuseful to move a sort of light element like an empty container with a vehicle devised to move heavier units. So we can have 3 choices, and then the container is stored in the housekeeping. And then another time, RTG or reach taker or forklifts are used in order to arrange the better layout for the export operation. And then one container after the other, the RTG or the reach taker or the forklift are alimenting the terminal tractor in order to bring the container under the ship-to-shore crane, and then to load it in the vessel and to export. So, for instance, this is the typical export process in a port container terminal. Well, the same is the generic import process, where containers are arriving from a ship and then unloaded and then send it out to the gate. And well, it's not exactly the same that inverting the sense of the process. There are some differences, but in general we can say that the process is quite the same inverted. And also the transshipment, here you can see the diagram referred to the transshipment operation. It's a sort of unloading, rearrangement, and then loading. So more or less we can resume the transshipment operation in this term. So the subsystem indicated in the first diagram, the subsystem devised to delivery reception, is not involved in the transshipment operation. Okay. So well, okay. The final, another operation typical in a terminal container is the housekeeping. In other words, housekeeping means to translate, to change the layout of the containers in order to facilitate and to optimize the subsequent loading or unloading phases. It's a typical operation of rearrangement in the storage area, in the yard area, in the temporary storage. Okay. Okay. So once we have defined the processes, the working processes in the port container terminal, we are able to make measurements about consumption. And it is exactly what we have made in the first phase of the Green Crane project, analyzing both electrical and fuel consumption in the container terminal of Valencia, Livorno, and Koper. As you can see, well, the figures in their absolute value are slightly, are different, because you have 19 million kilowatt consumed by the terminal of Valencia, compared with the 9 million of kilowatt consumed by the port of Livorno, or 5 million kilowatt consumed in the port of Koper. But of course, absolute values are depending on the volume of the traffic, of course. So Valencia is a big container terminal, moving up to 4 million containers. The Valencia port. The Noatum terminal moving up to 2 million containers per year. So it's a huge container terminal. While the maximum capacity of the Livorno terminal as maximum capacity is around 1 million. But in 2011, we moved 640,000 units. So the overall volumes is quite different between the terminals. But it's interesting to note that the percentage of consumption are more or less comparable. You can see that in the main container terminals, as obvious, of course, reefer containers are the main source of consumption. Reefer containers are refrigerated containers, so in certain sense it's obvious that they have consumption level higher than other operations, of course. And you can see comparable percentage in the lighting, the yard lighting, the light of the yard. Comparable values also, quite comparable in the STS cranes operations. So it's quite interesting to make a comparison like this, because you can not only focus differences between one terminal and another, but also you can see, you can note some differences in the organization of the processes that are not exactly the same. This is in terms of electrical consumptions. These graphs are referred to fuel consumption in the three terminal in 2011. One more time, you can see absolute values are different. 6 million liters consumed by the terminal in Valencia versus 1.3 million liters consumed in Livorno and 1.4 million liters in Koper. So absolute values, of course, are depending on the volumes, but percentage in this case are more different than in the previous case. Why? Because we are talking about fuel, and fuel is used for moving vehicles. And the use of vehicles, the more vehicle I use in a terminal, the less the terminal is well structured. I mean, a well-structured terminal uses it. Can I say it is able to keep the use of horizontal translation at a lower level, but other terminals with other kind of organization in terms of work, or minor organization in terms of work, have a major use of horizontal translation vehicles. So on another point of view, we can say that the use of vehicles is also an indicator of the good level of organization.
Me dijo no que está una porque todo le parecía increíble y muchísimo.
Se estaba escuchando el ruido de aquí del...
Okay, and this is in terms of fuel consumption. Okay. Okay. After having measured the level of consumption in terms of electricity and fuel, we are able to calculate the carbon footprint. Carbon footprint is a useful indicator for all kind of organization to measure the environmental impact in terms of greenhouse gases emissions. As you know, of course, the carbon footprint is a term used to describe the amount of greenhouse gases caused by a particular activity or entity. The methodology used in this study is based on the guidelines developed by the British Standard Institute in cooperation with the Carbon Trust and Department for Environment. These specifications are based on the methodology of the life cycle analysis, and in particular the ISO 14040 and 14044 2006, but also using the ISO 14021 eco-labeling. The methodology described can be used to analyze GHG emissions of the life cycle of virtual any product. GHGs are gases present in the Earth atmosphere that reduce the loss of heat into space. So they primarily include vapor, carbon dioxide, methane, nitrous oxide, and certain fluorinated gases used in commercial and industrial applications. Well, the approach used to industrial applications is focused on their activities, processes and services provided during ordinary operation. And this is the method adopted in this document. In this way, the carbon footprint has been determined, taking as reference the energy consumption of terminal, disaggregated by type of energy source, electricity or fuel, and for each type of energy source, emission coefficients are defined in order to obtain GHG emissions produced at the consumer point derived from the use of each type of energy. So specifically, we have used conversion tables in order to exactly convert consumption figures in equivalent GHG emission figures. And these tables are specific for each country, because normally are ministries that are in charge of elaborating and distributing this reference table for calculations, conversion calculations. So we used the official table, the official conversion tables, in order to obtain the equivalent CO2 equivalent emissions. So in order to calculate the carbon footprint in ultimate analysis. Okay. And this is this is the result. As you can see, these are the number referred to Valencia, Livorno, and Koper in terms of footprint. You can see in the graph in green the percentage due to electricity, and in blue the percentage. Sorry, in green the percentage due to fuel, and in blue the percentage due to the use of electricity. Well, as you can see, values are more or less comparable, because we have a total value of 12 kilograms of CO2 equivalent per TU in Spain versus 18 in Italy, in Livorno, and almost 16 in Koper. And this makes sense, because these figures are calculated dividing the total consumption with the volumes of the traffic volume of the container terminal. So this is an indicator per unit, per movement, per TU. So it makes sense that now the values are more comparable than before in terms of absolute values. And in the diagram below, you can see the distribution of the carbon footprint in terms of different vehicles or equipment used. Okay. So the first and clearest results of the study carried out is that port container terminals are huge energy consumers, especially those on those where energy is based on fossil fuel. Average values show a yearly fuel consumptions of almost, well, aggregated amongst the three ports, of almost 10 million fuel liters per year, including the three terminals participating in the analysis. This figure gives the real dimension of the high energy intensity needed at container handling operations. In terms of environmental impact, well, a great economic, environmental, and social impact is deriving from the massive use of diesel oil for developing no-stop operation. From the economic point of view, the general increase of fuel prices is affecting port installations, representing more every day a significant cost, which reduce their competitiveness and forces PCTs to assign economical resources to fuel supply. This fact increases their opportunity cost and limits the capacity for investing in profitable action or areas of organization. In terms of environmental impact also, the use of the current fuel in a non-stop operational model generates a great amount of GHG emissions, with an estimation of nearly 25,000 CO2 tons derived from the use of diesel oil at the three participant PCTs in 2012. Aggregating the information obtained in the analysis for 2011 and multiplicating the carbon footprint indicator by the expected volume in 2012, we can also expect this figure for the year. So this is in terms of fuel, but as we've seen, another important energy sources is electricity, and in the present study, ship-to-shore cranes and reefer containers are the heaviest consumer centers, representing 70 or 80% of the total electrical consumption in the three terminals. So, and we can calculate an aggregated total consumption of 33 megawatts in 2012 for the three terminals that are representing around 15,000 CO2 equivalent tons generated. Well, big port container terminals can be defined as important GHG emitters at the same level of industries or heavy industry. And considering the aggregated carbon footprint generated by the three terminals, the global value reaches the 45.68 kilograms of CO2 equivalent per TEU, considering the aggregated traffic of almost 3 million TEUs in 2011, which is the year with complete information for carbon footprint calculation. Social impact. Social impact is something also important in terms of calculation of green carbon footprint, because port installations are usually located near the cities or urban areas, or this is the case of Valencia, Livorno, Koper, Genoa, and many Mediterranean cities. So it is important to evaluate the emission level of the port operation, and more specifically the port terminal, container terminal operation, in order to establish the level of contamination and exchange between the port and the city, viewing or looking at the port as an industry, because finally the port is an industry. In fact, impact of port operation affects directly nearby population, not only in terms of direct emission of greenhouse gases derived from diesel oil, but also there are other pollutants. Have we seen before in the lecture before, water ballast and refueling or mooring of ships. Well, are all operations that are producing a certain type of pollutant. So, and also electricity, of course, not only fuel, because electricity does not produce direct environmental impact in terms of emission in ports or their neighborhood cities, but its generation in power plants produce also indirect GHG, which must be taken into account when describing energy consumption maps in the port terminals. So so we can say that efforts to reduce fuel consumption and GHG emissions produced by the main vehicles used in port container terminal as RTGs, yard tractor, and reach stakers are strongly recommended. And well, the Green Cranes project intends to adopt specific countermeasures for facing this kind of problem. As you can see, the first phase, the energy profile, was an activity absolutely needed in order to proceed with the project, because it could be completely unuseful to develop pilot or prototypes or experiment without knowing before exactly which elements are the main responsible of emissions. But having carried out such study that given us precise information about not only the terminal organization, but also information about the level of emissions, allow us to define specific countermeasures for facing this kind of problem. In particular, real-time monitoring, connecting port machinery with IT supporting systems. This is important because we can connect trains, LPGs, reach stakers, and the other vehicles to a general IT system that gathers increased consumption, fuel, and electricity. Control system that knowledge the second is try to substitute diesel oil with alternative fuels. And in this sense, we are developing two pilots, one in Livorno, one in Valencia. In Livorno, we will try to substitute the reach staker engine using probably LNG engine. So the idea is to have a LNG fueled reach staker. While in the port of Valencia, they are opting for another pilot. They will try to adapt terminal tractor that are the sort of shuttle between the yard and the STS crane. They will adapt terminal tractor to be fueled by LNG. So terminal tractor, and so if we combine the electrification of RTG, the adaptation of reach staker, and the adaptation of terminal tractor, these are the three main, if you remember the figures in the analysis, these are the three main pollutants in the terminal. So if we have success with this project, we can expect a significant reduction of the emission level for the port container operations. So this is the real objective of the project. Well, LNG is a clear candidate for alternative fuel for this kind of vehicles. But we have to study it, because it's not so easy to adapt vehicles to be fueled by LNG, and there are limitations specifically in the supply chain and in the availability of the crude LNG. So this kind of alternative has to be studied with attention, because it's a promising technology, but it requires that many elements are integrated one with the other in order to be economically viable. Okay. So I think we can stop with the green cranes description, and if you want to if you have some question about green cranes, and then we can pass to the energy and gas in the Livorno.
Is the port of Livorno, in terms of the human resource, ready to accept this project, and in general the idea of the greener port?
Well, good questions. The answer is it's our job to prepare that the port environment to accept this kind of innovation. I have to say that in the green cranes project we had Terminal Darsena Toscana, that is a private company, as a stakeholder member, and I have to say that they have cooperated with a great enthusiasm to this initiative, because finally the acceptance of the green policies, it's strictly depending on the economic viability of that policy. So if entrepreneurs and companies found that some green investments are viable, they of course are enthusiastic about that. In this case, since it seems that the LNG alternative for a port operation could be really viable if we can solve some other problems like supplying, that is complicated. But the technology itself is very promising. So companies itself are enthusiastic about cooperating in this sector. So the answer is it depends on the money, of course, because economical viability determines the grade of cooperation of private companies. This is in terms of system. In terms of human resources, if human resources are ready for operating in a greener environment, well, it depends on the grade of information and training that you are able to provide them. As Port Authority, we have a training center accredited and certified with quality certification, and we organize on a yearly basis courses on safety, environment, first aid, and well, general issues regarding the basic of the port operations. So we, as Port Authority, we are directly involved in the process of forming a sort of awareness about the green economy or the green operations. Of course, private company have to do the same, but I have to say that the reaction founded until now is positive. So I hope for the future. Okay, so let's now have a look about the energy and gas. As you can seen before, the green strategies in the Livorno port are focused on several axes, but energy is one of the most important, of course, together with innovation and knowledge. Why we are spending some minutes of our afternoon talking about gas? Because it's I can say a key element for the future. Gas, or well, for Livorno is surely a key element for the future, because Livorno is hosting the second gas facility in Europe per dimension. Starting from 2015, Livorno will host one of the 3 regasification units foreseen in the National Energy Plan. And we are involved in projects like Green Cranes or in other projects that are studying solutions in the LNG sector or in the alternative fuel sector and so on. So I think that considering all the elements available in the Livorno port, it could be interesting to focus our attention to the gas issue. Well, the gas and the energy, of course. Well, Livorno Port Authority is not a direct energy provider, but as a port management authority and public investor in port general interest infrastructures, the policies adopted by the Livorno Port Authority master plan and their related decisions can have a direct impact in also in the port energy sector. So in the port energy sector, yeah. So the port of Livorno, as any other complex economic system, is I would like to say that I don't know if everybody is aware that a port authority, Italian port authority, are public bodies that are in charge of designing the development plan of ports. And one of the major activity in charge of a port authority is the designing of the port master plan. The port master plan is the official document where future development of the port are clearly stated and technically explained. So it's a sort of action plan for the future. Each port authority is obliged by law to produce the port master plan every 3 years in order to have a sort of planning of the future activities, investments, and developments every 3 years. So this is one of the most important part of the port authority job. So this is the premise. So the Port of Livorno, as any other complex economic system where networks of different production activities are interoperating, is with no doubt a significant energy consumption center, characterized by several components, as those referred to ships approaching and mooring, cargo handling through different kinds of cranes and heavy trucks, yards lightening and building powering. In this context, any action aimed at lowering the energetic dependency, making the use of energy more efficient and reducing the emissions level could play an important role for each future development, especially considering the cost rising trends of fossil fuels and also the need to comply even more strictly to those regulations devised for bringing down the environmental impact of production processes and improving the sustainability. So, lowering the energetic dependency is one of the key elements. The Port of Livorno rationalization and growing policies shall foresee also its parallel energetic development, which has to be based on a sort of, how can I define, mind changing in terms of energy decisions, because Livorno Port should gradually change its status from energy consumer to energy producer, because now we are a huge energy consumer, but the idea is to adopt solution and foster innovation in order to become an energy producer, even a small scale energy producer. I mean, it's not important to transform a port in a power plant, but lowering energetic dependency of port operation could be a key element for the port development. So, and this is the real mind changing. In order to pass from a work organization based on consumption of energy, and so on emissions of greenhouse gases and so on, to the concept of green port. A green port is not dependent, or at least is less dependent from crude oil, from diesel and so on, and is probably producing part of the energy used in for its operations. So this is the idea. And so on the other hand, we have also to take into account all the aspects related to efficiency. It's not only a question of producing energy, but also try to reducing try to optimize the use of the energy, so to strengthen the efficiency. That is an important concept to be declined not only in terms of future infrastructure development, but also implementing real-time monitoring systems and carrying out maintenance activities. Also, maintenance is important. Focused on the gradual substitution of highly consuming parts with their eco-efficient counterparts. So the planning of the eco-efficiency is in several directions. So policies, when we are thinking in a port master plan to future terminal, future investment, future infrastructures, we have to plan these infrastructures or these investments having adopted a green mentality. This is the first. The second is to pass, not quickly, but to pass from the status of energy consumer to energy producer. This is the second aspect. And third, in terms of maintenance, to gradually substitute all the highly consuming part with their eco-efficient counterparts. So these are three aspects that can improve the environmental impact of port. In particular, in order to carry out actions useful for getting closer to these elements, the action will have to be oriented to the creation and the integration of small-scale renewable energy power plants, or better, the creation of a small energy district or smart grids, that is something very very modern. So one of the issues of these courses is smart cities. So smart grids are surely part of that vision of the future. And focusing in particular with solar energy through the individuation and the utilization of available areas in the port for installing solar panels and photovoltaic system. And also, as Port Authority, through applying specific policies for favoring, I mean specific policies in terms of concessions, for favoring the adoption of the solar energy from the companies operating in the port. And the second, the wind power, in terms of designing and development of small onshore or offshore power plants in harmony with the future port expansion plans. So another idea could be the creation of small wind power plants, small scale, in order to augment part of the electrical needs of the port. And another important issue is green quays. So this is a topic highly adopted in the Northern Europe ports, as is the adaptation of the quays for electricity in order to have the possibility of cold ironing services in cooperation with shipping companies. And also, even if in terms of studies, because the technology is very young in this sector, the possibility to develop wave energy. As you know, also waves are a source of energy if properly used. So one other thing we can study on is the possibility to mount or develop or install a small-scale wave energy plant. But this is a future activities because this technology is quite young. Very few in the world are the plants in using waves. So in this phase, we can foresee only preliminary studies in cooperation with research centers and universities for evaluating the potential, the available potential for in terms of wave energy. And other thing that we can make for getting closer to the green port policies are solutions for increasing eco-save and eco-efficiency and the fossil fuel needs analysis and studies. Well, in other words, what we are doing with the green project, with the green crane project, and also the integration of energy decisions with the Port of Livorno infrastructural development policy framework, with particular focus on energy and production network safety due to their proximity with urban areas. So it is important to keep in mind that the Port of Livorno is very near to the Livorno, to the city center, so each decision have to be made also thinking to thinking to this proximity. Okay. So talking about gas, we can divide the issue in two parts, LPG and LNG, because are two different technologies that are involving two different logistics systems, two different transportation systems, and well, it's gas, both LNG and LPG, but they are very different in terms of use and especially transportation and stocking. So it could be better to talk of them as two separate issues. So LPG. LPG, as you know, is liquefied petroleum gas, also called ZPL, LP gas, or propane, or butane, or whatever name you want to give to LPG. It's a flammable mixture of hydrocarbon gases. As you know, it is increasingly used as aerosol propellant and refrigerant, replacing chlorofluorocarbons in an effort to reduce the famous damage to the ozone layer. And when used as a vehicle fuel, is often referred as autogas. So, well, LPG is well known. LPG is prepared by refining petroleum or wet natural gas, and it is almost entirely derived from fossil fuel sources, being manufactured during the refining of petroleum, the crude oil, or extracted from petroleum or natural gas streams as they emerge from the ground. So, LPG currently provides about 3% of all the energy consumed in the world and burns relatively cleanly with no soot and very few sulfur emissions. Well, as it is a gas, it does not pose ground or water pollution hazards, but it can cause, of course, air pollution. And, well, all of us knows that LPG is becoming widespread worldwide in several sectors as motor fuels, for heating, for refrigeration, and for cooking. So it's for sure a promising element in terms of alternative source of energy. This is a diagram explaining the supply chain for LPG from the wells to the gas plant and the transportation and the storage in intermediate plants, and then the transmission of the gas through the gas networks or through trucks or whatever vehicles we can use for transport natural gas. So this is a global vision of the supply chain. But Livorno is particular because the Port of Livorno is hosting the Costiero gas facility. The Costiero gas facility is the most important Italian LPG storage facility, and it is the only that has underground storage possibilities in Italy. Underground storage is a particular technique of storing natural gas in cavern, in artificial cavern, in order to avoid safety problems that we can have by using the tanks, external tanks. So, well, the Costiero gas is the only facility in Italy that has a cavern, underground cavern for gas storage. And it provides, at the present, I'm talking about 2012 figures, 25% of the global Italian LPG needs. So it's a huge amount of gas handled in these facilities. And also, since, as we can see in the next slide, as the Costiero gas has its own facility for vessel berthing, it also can be refueled by the mooring of large LPG carriers. This is the location of the Costiero gas in the port of Livorno. Well, the Costiero gas is part of the Eni group, And it is located, as you can see in the picture, in the industrial canal of the Livorno port, in an area characterized by both industrial and port settlements, including the Eni refinery that is quite important. The plant is built over an area of 106,000 square meters, and the substance handled and stored inside underground cavern is LPG commercial propane mixture C, to be precise. The available facilities in the Costiero gas terminal are 11 loading points for road tankers, 3 loading points for rail tankers, 2,010 meters of private quay inside the industrial docks for discharging LPG carriers, of course pipeline for transfer and stock, rolling stocks, 6 extraction and insertion pumps, and 3 underground caverns with submersible pumps. These are the overall facilities available in the Costiero gas terminal. These are the facility location. As you can see, the quay where vessels are berthing, the rolling stocks, the loading items for road tankers and rail tankers that are the facilities used for loading the trucks and the rail tankers that exiting the terminal for export. If we can use the same mentality of the terminal, of the container terminal, we can think that the import operation in the Costiero gas is when the ships arrive to the terminal and unload the gas into the underground cavern. This is the import process. The export process is to extract gas from the cavern and to load trucks and rails and rail tankers in order to export the gas outside the terminal. So these are the two processes in a certain. Well, this is interesting. This is the only existing photo of the underground cavern, the only remaining photo of the underground cavern from 1963. I don't know why, but they do not have any more photographical documentation about that period. Probably an accident, probably material have been lost, but this is the only photo remaining of the construction of the facility during the year 1963. The cavern, here you can see a 3D perspective of the caverns. I have a maximum capacity of 45,000 cubic meters, and an operational capacity of 33,000. 34. Of course, the operational capacity is less than the maximum capacity in order to foresee some expansion space for the gas to expand. It depends on the temperature, of course. These are the figures of this facility. We had in 2012 45 LPG carriers that have berthed at the private quay of the Costiero gas, unloading a totals of 445 kilotons of LPG in terms of import. Well, the export is the same because the company is operating in a real-time policy. What the company buy in terms of gas is exactly what the company sell in terms of gas. So it's not a surprise that the figures are the same in import and in export. And the total for 2012 are more, well, around 2,000 rail tankers, around 20,000 road tankers, and two pipeline transfer and stocks towards any refinery neighboring. So these are important figures. They represent 1/4, the 25% of the national Italian needs in terms of LPG gas. Well, the bulk storage of LPG in caverns offers these advantages in terms of safety, because safety from the hazard of inflammable gas leakage, and offers also land economy and lower capital cost and lower operating cost compared to conventional pressurized spheres and refrigerated tanks, because they are covered and stop, and better inherent safety over the above ground storage system, and also safety from calamities and also eventual potential forms of sabotage. So storing in caverns is undoubtedly a safer way to do this job. Well, so this is the LPG facility existing in the Port of Livorno, and it is surely a relevant facility in terms of gas. Now let's spend some words for the LNG factor, trying to analyze this factor. Well, LNG is liquefied natural gas, mostly methane, in its liquid form. And the liquid form, as you know, is achieved by reaching a temperature of minus 161.5 or 2 Celsius degrees. In other words, the same amount of gas in its liquefied status occupies a volume 600 times smaller than in its gaseous state. So this is the sense of having liquefied natural gas. Because a single LNG carrier ship can contain large quantities of gas, making transportation economically viable. Because, of course, the technology used for liquefying the gas is costly, but the advantages that we have in the compression is such that the transportation is viable because the volume is 600 times smaller. In fact, one LNG carrier can transport about 130,000 cubic meters of LNG that are equivalent to about 80 million cubic meters of the same product in its gaseous form. So the comparison is between 130,000 versus 80 million. So it's a very significant ratio that makes viable the transportation of LNG. It is a gas with huge potentialities of global level trading through storage facilities and ships that are specially designed to tolerate, of course, low temperature, because LNG has to be maintained at temperature of minus 161 degrees. And well, although production costs are among the highest of any fossil fuel, of course, higher than crude oil or LPG, technological improvements have reduced these costs by 35 to 50% over the last 10 years. So LNG is becoming also viable also in terms of extraction or production. As a result, the LNG market is expected to double in size by 2015 to more than 40% of the world's natural gas supply, compared to 26% 2005. And one important fact is also that almost 90% of the world's potential natural gas reserves are beyond the pipeline export reach. This is important because if I am a country that I have the possibility to produce, that I have natural gas in my ground, but I have no facilities, no infrastructure, no one that would invest in my territory in order to extract this gas, well, the LNG solution could be a viable solution because I can extract the gas and then transport it without having the need of a pipeline, because pipelines are a costly infrastructure. So the possibility to transport LNG via ship permits to other countries that do not have a network of pipelines, give them the possibility to exploit this natural resource. And this, of course, indicates an enormous potential demand of LNG technology. In this picture, we can see a diagram of the logistics chain for the LNG in terms of export terminal, transportation, and import. Well, of course, the key element of the technology is refrigeration from one side and regasification from the other, because the significant part is transportation, is the transport of the gas. In order to transport LNG, I have to refrigerate and to compress the gas. And for do that, I have to refrigerate the gas on the departure and to heat the gas on the arrival in order to have it in its gaseous form for distribution purpose. So regasification is a system that converts methane gas into liquid form in the producer countries, so it can be transported by ship to the consumer countries where it is regasificated. It is brought back to in its gaseous form and introduced in the network, distribution network. The regasification process is obtained by introducing the gas into so-called heat exchanger, where a warmer liquid flows, normally seawater, at natural temperature, heats the LNG, bringing it back to the gaseous state. Transport by sea is an advantageous alternative, allowing gas to be bought freely through the world without being tied to a gas pipeline connection. This allows consumer countries to be supplied regardless of existing gas pipeline networks. So it's an opportunity not only for the producers, but also for consumers that are not obliged to be linked to possible pipeline networks. And in effect, in Italy, the National Energy Plan of Italy foresees 3 regasification units, one in Rovigo, one in La Spezia, and one in Livorno. The one of Livorno is the OLT Offshore LNG Toscana. That is a company whose shareholder are E.ON, Iren, and Golar in different parts. Of course, Golar is very small. We can say that E.ON and Iren that are shareholders until the 90% of. The OLT Offshore LNG Toscana is the first company that has supported the regasification terminal project, and it is the company that holds the permits needed for the construction and running of the floating storage unit and the regasification plant, called FSRU Toscana, that is a ship, LNG ship, which will be positioned 22 kilometers offshore the Tuscan coast in front of Livorno and Pisa. So OLT Offshore Toscana is the company that holds the permit, and this is the company that is owned by the Golar LNG share. So it's quite complicated, but in any case, this is the framework in which the company is operating by a legal point of view. The location of the OLT offshore is in front of Livorno and Pisa. The regasification plant comprises a LNG carrier that has been suitably modified, and it is permanently anchored about 22 kilometers offshore between Livorno and Pisa. The gas will be transferred onshore through a 36 kilometers long pipeline, 29 kilometers under the sea, 5 kilometers following the floodway of the Arno River, and 2 kilometers on dry land. The gas pipeline will be completely buried at the minimum depth of 2 meters. The location of the regasification terminal was chosen at national level also because Livorno is a suitable port to support the unit's activities. Well, you can imagine we have a regasification plant based on a ship with all the needs that could have a ship. So having a port in around 20 kilometers could be useful in order for maintenance operations, for tugs, for any operation that could support the life cycle of the ship itself. So it could be an important presence, the existing Livorno port facilities for the running of the LNG terminal. And well, not only for this, but also Livorno, because is in a territories where the gas is mostly used. Tuscany is one of the regions that uses large amounts of gas with an annual consumption of about 4 billion cubic meters. So placing here LNG facilities surely could be economically viable. This is the terminal. This is the terminal exiting the Dubai shipyard, because the LNG plant, as I said before, will be operational in 2015, maybe. It depends, of course, on the also on the permission phase and all the administrative questions. But by a technical point of view, all things are ready in order to run the terminal, because pipelines are on site. The ships is now finished. So the only things that are missing are the administrative procedures and, of course, the physical transfer of the ship from Dubai to Livorno. Well, the project provides the conversion of a LNG carrier, whose name was the Golar Frost, now is FSRU Toscana, into a floating unit permanently anchored about 22 kilometers off the coast, so invisible from dry land, of course, which will transform the liquid natural gas back to its normal gaseous state. The unit will be anchored to the sea through 6 anchors with a single rotation point at the bow to permit the ship to move around the anchoring, adapting to the sea weather and to the weather and sea condition without repercussions to its activities. So it is a terminal, a regasification terminal that is permanently anchored in a single point. So we must foresee all the possible measures in order to have it in stable condition with every weather or sea condition. So the anchoring is a crucial element for having stability. And at full stretch, this unit will have a regasification capacity of 3.75 billion cubic meters per year, about 4% of the national requirement, and an average regasification capacity of 11 million cubic meters a day, and a storage capacity of 137,000 cubic meters of LNG. So this is the floating terminal. The process, the process from producer countries to Italy, to Tuscany, producer country to the gas extracted in the natural gas reservoirs are temporarily stocked in LNG storage facilities, then loaded into LNG carriers. Then the LNG carrier arrives to the terminal and unload its gas in a liquid form to the LNG terminal, that then provides to its regasification and send the gas to the pipeline and to the national network distribution. So the unloading of the LNG and the storage in the regasifier tanks. In this operating stage, the gas carriers used for transporting the LNG berth alongside the unit, aided by tugs. The LNG is taken from the ship via 4 mobile arms and poured into regasificate 4 spherical tanks. This is, well, the specific technology used in this case, because the FS Aero Toscana, the ship, have 4 arms that are used for transferring in the liquid form the gas from the tanker to the terminal. Then we have the regasification. That is the gas that is brought back to the gaseous form, and then the distribution in the national network. So these are the figures related to the terminal. So more or less the numbers we have already set. I have to be more quick. And well, another word for LNG is that as a Port Authority, we are a member of the stakeholder group of the Costa project. Costa project is a TEN-T project, another TEN-T project, who's talking about LNG, and more specifically about the usability of LNG as fuel for ships, as alternative fuel for ships. It is a complex issue. This is the one of using LNG for fueling ships, because many questions are involved, from supplying, retrofitting of ships, financial cost, and so on. So it's a very interesting issues, and challenging issues, but it is very promising, the using of LNG, because many problems could be solved by using the LNG also for the shipping. These are the issues that are constitutes elements of uncertainty regarding the using of LNG as fuel for shipping, technical, logistics, legal, and environmental. And these are the opportunities also of the use of LNG as fuel for shipping. It's a complex question. It could be interesting to discuss more about these issues, but I think the time for me is well at the end. Okay, thank you. And if you have any questions, I'm here. So,
yes, I have a question about the distance between the FRP, the Toscana, and the shore. The choose of 22 kilometers is only for seat reasons, or is because is a medium and average distance between the shore characteristics or other?
It depends on various factors. First of all, is is a questions of rules and safety rules, of course, and secondarily because the depth of the sea in front of Livorno is not suitable for hosting a facility of this kind, because there is a zone that have a smaller depth, and then another zone is already has been already declared a sort of natural park for the marine environment. So the point is the minimum compromise for, between distance, safety, and regulations. Thank you. That's all.
So, at the last, what do you think about to use LNG as a fuel for ship?
Well, if I have a quarter of hour more, I would like to discuss. What I think at the present is the scenario is quite uncertain, because producers are in a, well, because we have two different parts of Europe that are running at two different velocities. The northern part goes to the Marpol Annex 6 that you already know, are already facing the LNG problem by another point of view, and shipbuilders are more interested in building or retrofitting ships because the market is promising. I'm talking about Northern Sea. But about Mediterranean, the situation at the present, it seems to be a sort of a chain, because shipyards are uncertain if investing in building ships, because there are no supply network existing. On the other hand, the subject potentially interested in investing in supplying are uncertain because no ships are existing. So it is in this moment we are facing a sort of uncertainty for the Mediterranean, that we hope that projects like Costa and other initiatives could help to overwhelm this kind of uncertainty, because in effect LNG could be a good solution, for instance, also for addressing other needs. Let's think, for instance, to the water ballast of the previous water ballast management of the previous lecture. It was said that the problem was that it is energy consuming, and so as being energy consuming is also GHG pollutant. Yes, if you are using diesel engine, but if you are using LNG engine that have no emission in terms of sulfur and lower emission in terms of CO2, also operation like the water ballast management could be possible. So it could LNG is really a promising technology, but for its adoption in the Mediterranean, we have to work hard because many are the problems that are related to its development. Okay, a voi.
While we prepare the next presentation, you have 5 minutes of break.
Mi devo scusare che ci viene dopo di me. Mi scusi veramente, ma mi sono lasciato prendere la mano dalle parole.
È un appassionato del tema.
Sì, esattamente.
Sapevo che ho aggiunto lì. No, guarda, ti venga solo questo, perché che nelle mesi no, sono uguali, Infatti ho fatto delle robe che devono essere nella dico io, sono abbastanza pratica.
Però lasciamo lo spazio suo perché da qui direi qui positivo, quindi questo lì. Sì, sì.
No, sono quelli con il flag. Aspetta, che mi dico che era. Grazie, ok. No, no, ma se no io ho un problema col tempo, non è che nel senso, no. Ce la posso fare. Troppo gentile, troppo gentile. Quando vuole metta pure la presentazione, io faccio switch on. Ok. Okay, thank you for being here today. I'm Elisabetta Pina. I'm head of training and competences of the S department in Costa Crociere. Costa Crociere is the leading partner in Sustainable Cruise project. Sustainable Cruise is a project related to the ports, but it was born thinking about the ship, and I would like to give you a brief update on the project to provide you with a brief overview and highlight some key points that I would like to share with you. The project, first of all, I'm going to the overall objective of a project, that is reduction, reuse and recycling of the waste produced on board in order to improve the contribution of the maritime sector to the European commitment against climate change. When we started to think about sustainable cruise, we realized that even if we on the ship do a very straight, very precise waste management, in some ports when we offload the waste is put together and the port become the owner of this waste. So all the effort that we are doing in the ship, and we also paid some people in order to do this waste management, are completely disappeared completely when the waste is offloaded on shore. So we start thinking about a manner in which we can transform the waste in bio waste or second product level. So it means that it's not more waste, but it becomes a product and can be sold to some company ashore. The Sustainable Cruise project is funded by the Life Plus Environmental Policy and Governance. It has an economic value of 2.7 million euro, and the duration is from the launch was in September 2011, and it will last till June 2014. So we are at present in the middle of a project. The coordinator beneficiary is Costa Crociere, and the project includes a variety of other partners who represent different interests, each of whom has an important role in the implementation of the project and in the achievement of the results. For example, the CESISP is a group of universities specialized in research and in life cycle analysis. The MedCruise is the European Association of Mediterranean Cruise Ports. VOM, Impianti e Processi, and Content to Trade are two companies well known in the research sector. Design innovation is a design process consultant. The other stakeholders are Carnival Corporation, European Cruise Council, Comieco, Assocarta, and Federambiente. So we try to involve in the project a lot of other important stakeholders in the waste management field. So what we have done is basically we did in the first year a deep analysis of all the products that we are using on board, and and that becomes waste at the end of the process, and we try to think about the 3 R's of the European directive: reduction, reuse, and recycling, in order to focus on 3 types of stream waste: packaging, bio-waste, and paper. For the packaging, we are going to define a plan for the recovery of the 30% of the packaging. For the bio-waste, that is the core of the project, we are defining and acting a plan for the reuse of the 90% of the bio-waste. It means that we are going to reuse the economic value of 2,000 meter cube of bio-waste. That is the 100% of the food discharged into the sea from Costa Pacifica, that is the pilot ship of the project. It is about the 6% of the entire bio-waste of the Costa ship. Other further objectives of this project are to maximize the opportunity of the waste recovery, to improve the energy efficiency, changing some process with innovative techniques, to capitalize the results, and to transfer the results to other industry, for example in offshore, because what we realized is that it is more simple to analyze the waste management and the life cycle analysis in the ship, because this ship is a closed system, so you know for sure what goods are uploaded and what goods are offloaded ashore. Sorry. Then to create an Euro-Mediterranean network of ports for the cooperation in the management waste that is offloaded to shore. As I told you before, we realized that there were no shared information about the waste management in ports. So each company has to ask every time to the port the kind of goods that we can offload, the prices, and there were no shared information. So the port of Savona have some tariffs, and the port of I don't know, Civitavecchia, for example, had other tariffs. Then we would quantify the reduction of carbon dioxide emission deriving from sustainable management of shipboard waste as a first step for the application of the Kyoto objective for the reduction of CO2 to the maritime sector. In the shoreside sector, as you know, there are some methods in order to understand how does a build impact in terms of emissions. For the ship is different, so there is no shared method in order to do that. So it could be a first step to create a shared method for doing this. To define a new type of voluntary certification regarding the treatment of waste on board ships for anticipating and orienting the European regulation on this thing. As you can imagine, these kind of projects are funded by the European Union also to understand what is going on in some sectors, and the ship sector is not a sector very mature from this point of view, because the ship sector is a sector in which the shipbuildings start to improve the creation of ship, the building of ships within the previous, I think, 8-10 years. 10 years ago, there were not such a lot of ships like now. So let's move further. The action are the packaging stream, the biodegradable waste, the paper stream. Then there are some horizontal action that are the waste offshore governance, energy efficiency, energy efficiency management, and the normative analysis and certification. Because when you are the first that is doing something in every field, I think you have to certificate everything, because nobody knows about what is going on. This is the project timeline. At present, we are building our turbo dryer that will be installed on board in October. So we will have 1 year that will be the field trials phase. In the middle of 2014, we will have some results. These are the results of the first analysis that we did, and we take into account 3 different cruises during the summer season in the Mediterranean. I don't know if you know, Costa Pacifica is one of the biggest ships of Costa Cruise Line, and it can have about 3,500 passengers and 1,000 of crew members. So there are about from 4,000 to 5,000 people on board. And in terms of packaging, we realized that we were using 24,000 bottles of water per cruise. So it means 7 days. 15, okay, it was summer, so people drink a lot summer. But it was just a little bit shocking also for us, because 24,000 bottled waters is really a lot, also in terms of packaging. And for example, 9,600 yogurt pots. So okay, maybe that during the breakfast all of them were having yogurt, but it's a lot. And we analyzed this kind of results, and we concentrate our efforts in change action. The analysis of the pilot ship showed that the most significant packaging materials in terms of absolute inflow quantities were paper, glass, aluminium and plate, aluminium tin plate and plastics. So I would like to update you on the environmental impact of these materials. The larger quantity were glass, aluminium, plastic, and fiber cardboard. That means, if you look at the total, the using of a car for 1 year for 1,000 passengers, and the emission for a small industrial plant. It's quite a lot, so we decided to, okay, we are talking about CO2 emission equivalent, but we decided to do something in order to make the situation better and better. Oh, grazie. I will notice you on this chart. From the first step of the project, we moved, starting from October 2012, from glass water bottles to plastic water bottles. Moreover, at present, we provide forfait package private glass, further to avoid the use of more bottles. It means that you buy a forfait, and every time you go in the restaurant or in the bar, you take a glass of wine or of water or what else, and it allows us to do not waste bottle of water. The future step can be the complete regeneration of the PET done on board. So we are thinking about moving from a garbage room to a recycling factory on board. That is a very interesting but also ambitious project. So we have to face a lot of obstacles, also from the point of view, also from the legal point of view. So this is the scenario of what happened because when we started with the analysis. Scenario A was the waste incinerator on board and the disposal ashore. So after, when we moved from the glass water bottle to the plastic ones, we reduced the CO2 emission of about 50%. I don't know if you know something about that, because in the common perception, that was also mine, the glass have a less impact than the plastic from the point of view of the emissions. But in reality, it's not that, because it takes more bad emissions in order to transform or to create a glass bottle instead that are necessary to create a plastic one. And moreover, it's simple to regenerate plastic and to do other goods, such, for example, I don't know, the pile clothes that we have at home, than for the glass, because the glass have to be of one color. For example, you can't mix the brown glass with the white one, and so on. What we are thinking about is to the PET regradation on board, the regeneration with the machine, the turbo dryer machine, and we will move to the reduction of the 60%. So we are thinking about doing something more. Sustainable cruising is considering also the reduction at source of the other goods. For example, the yogurt pots will be probably replaced with the yogurt dispenser, and we would like to transform some waste on board, and we are thinking about a shore recycling, so to start the cooperation with some factory ashore in order to try to recycle things. This is the situation. Was the picture of the biodegradable waste that was the 22% of the total waste produced on board. And that represents the heart of the project, also in terms of innovation. The starting point picture was that we were uploading a great variety of goods and a big quantity of that. As you already know, during a 1 week ship, the people have a great variety of menus on board and eat almost all day long, because there is breakfast and then a second breakfast and then lunch and then the, how do you say, merenda, and then the dinner, and then after dinner menu and so on. So, but we have to balance the service that we offer to the people with the sustainable cruise. So maybe that we are going in the sustainable cruise pilot, going to reduce or saying to the people, listen, this is a sustainable cruise. If you do not do some plates of food like that, it's better. So we do not want to go. But from the other hand, we have to provide a service, and the people, for the people, usually the cruise is like a dream. So everything is for free, and they have a perception of that they can do whatever they want. So we have to balance these two aspects. In order to reuse bio-waste shall be treated and transformed, and this will be achieved by experimenting the application of 2 different technologies. The main one is the direct treatment using the turbo dryer, and the other is a EDC, an integrated system that can be done subsequently. What we have done, a sample program was performed to allow VOM and Contento Trade, that are our partner, the analysis of food waste composition. A radar sensor was installed on board in order to monitor the levels of pulper. The pulper is something that, a machine that reduces the food in small pieces after the watering. That is mean that in order to reduce the waste in small pieces, you have to add some water. So a first assessment performed to identify the applicable legislation and existing constraints on food waste recycling excludes the reuse of food for farm animals. So maybe that we are going to, what we can do is to create a product that can be sold to the company that create food for pet animals, so cats and dogs. The VOM complete the first set of sets, and the food residues can be treated upon 2 different stages. To reduce the content of the 50%, and then more of the 5%. This is what this is a picture of the results of the waste. So it can be, it's brown, at something similar to salt. The consistency is more or less similar to the food animals. And after that we analyzed, and it resulted that this is the ideal composition that can be used for pet food. Now we have to find somebody that is going to buy it. At present, what we are doing is evaluating the hypothesis of moving from a turbo dryer dedicated only to bio-waste to a multiple turbo dryer that can be treat also other streams, so paper and plastic. Processed paper waste mixed with water can be reused for asphalt industry, and the plastic can be regenerated for reuse in the plastic industry. So what I told you before is that we are trying to think about moving from the garbage room, that is the room when on board the garbage is treated, to a recycling factory. So the goods that will be the results of this treatment will be no more waste but products. The pros are: we will achieve the project results, there were a lot of environmental benefits, and there can be also an economic benefit, because the company, when the company arrive in a port and offload waste, has to pay. And in this case, if you do not have more waste but products, somebody will pay for you in order to buy it. Okay? Maybe that we are going to sell it and give some percentage to some onloose or in 12 people and so on, but in any case the cost will decrease. The cons are the regulatory constraints. So we are now facing some problems about the environmental aspects, and so an environmental consultant is consulting us understand if it's feasible or not. And then the company, of course, has to do some investment, because nothing is for free. This is the situation about the paper, and also the paper was a huge quantity on board, and was about the 16% of the waste produced on board. There were a lot of paper sheets, dispenser, toilet rolls, daily program flyers, and so on. And we divided in our analysis the paper in 3 different streams: the packaging, the consumers, and the communication. So the packaging, we are thinking about the reduction of the packaging and transformation with the machine that I told you before, wet dry pulper fiber pulp. The consumers with more we are trying to replace the consumer with more environmentally friendly products. The communication, that is also a huge number, we are trying to reduce with the communication with digital application, to substitute the communication with digital application. Of course, we can't go and reduce up the 100% that, because not all the people are user friendly with the the, I don't know, smartphone or with the iPad and so on. So we have to maintain, of course, a certain number of paper on board for older people or for people that are not friendly with this kind of instrument. We are creating some guidelines for paper, for crew members, and also for guests. In a very nice way, we are going to say to them, remember, for example, remember that it is a sustainable cruise, so if you can try to avoid using paper, it's better, and so on, but we can't force the guests in order to do that. We can only suggest to the guests. Okay, we can go more straight to the crew members and to my colleagues, for example, but not to the guests. And the transformation. We are going to create creative labs in order to create also such a kind of sustainability awareness on board, from the point of view of a guest and also from the point of view of the crew members. This is what we are doing about the digitalization actions. Sorry. There is on board the, let me say, something like a newspaper that is called the Today. Is a daily program of all the activities that are running on board, and it is printed usually in a whole quantity of languages, about 6-7 languages, because for if you are Romanian or for if you are Chinese, it's printed in Chinese and so on. And for those people that are going to ask, so to agree in order to have it in the web, we are going to cancel the paper format. This is a way in which it will be substituted. So, what about the target for the guidelines? There will be the guest, the shoreside personnel, and the crew. So we and the communication format will be different. There will be a visual graphic communication format, some short guidelines, some formative activities, and also detailed manual for the crew and for the shoreside people. This is an example of what we are going to do. The first one are some rules that we are going to put in on the internet for the guests and on the internal the intranet for the crew member and for the shoreside personnel. Then there will be also some pop-ups weekly that we will change weekly with some tips, and each of us will find it in the PC. For example, remember to not that it's better to not print all the email that you receive. And these are some example of creative activities that we are going to do with with our guests. In the ship, we will put some basket like this one, where the people can put the paper, and then we are going to propose some creative labs in order to create something with the same paper, and also some quiz with questions about sustainability for the older guests and also for kids, because it's very important to start with the kids and try to grow up the awareness about sustainability. And this is the last slide. I was very quick. And we are trying to do the analysis of the best practices of the waste management in the port environment. So we asked to all the ports, we provide to all the ports connected with MedCruise a questionnaire in order to understand what is going on in each port member of a MedCruise. And then we are trying to create a website when each port can put all information about waste management, and the MedCruise will coordinate this activity. So each shipping company, not only customs, also all the other, can find there all information about the port and the waste management, the tariff, who is the owner of the port authority, the contact details, and so on. So everything will be shared, and let me say, everything can be transparent. That can be better, I think. Then we are doing some normative consistency and certification. Our legal counselor is starting the first step of the analysis. We are doing a lot of network and mainstreaming and dissemination things. And what we will receive in the next month will be the first life cycle analysis about the plastics on board, and then about the other action that we are running. I think that I finished. I don't know how many time, but if you have any questions, or you can ask.
Question?
I think that they are almost died now.
Just one question. In the project, do you evaluate the impact of this solution as concern CO2 emission?
Yes, of course.
Could you tell us?
We have analyzed the CO2 equivalent emissions, and as I told you, for each stream that we are going to attack, we are going also to evaluate the CO2 emission impact. So from the moving from the glass to the water bottle to the plastic ones, we have reduced the CO2 emission of 50%. So this is only about one ship, but each action that we are doing for the pilot ship, and if we see that it works, we are spreading it in all ships. So we started for 2 months changing from the glass to the plastic in Pacifica, and then we spread it in all ships, Costa and Libero cruises, because we realized that it works.
A question about the sustainable program. This kind of program bring also money saving for the ship owner or not?
No. Some actions, yes, but honestly, what is our when I started to look for funds in the European Union, the thing was that we agree that we were going to present projects only if this kind of project were projects in which the company believe, and then we were doing to do something in any case. It helps because you can share. I think that it's not a question of money, it's a question of having a relationship and sharing things with important or with let's say other partners. So we are using for the life cycle analysis the 3 different university. This is the added value for us, because honestly, what I did a meeting last week with my vice president, and I asked to him to give more money to me for the project, because if you start doing something and you believe in something, you have to invest. And it was so let's see. But I think that for example, we started thinking about the pilot only for the waste on board, and the pilot, the turbo dryer that we are going to put on board, cost I don't know, for our partner it cost about 600,000 euro. And but at the end of a project, we have to pay, because we have to pay the difference, because it will stay on board for 1 year, and then the pilot is not our, is the pilot, then the machine is not our, is of our partner. So I asked my vice president if he would like to invest more money and have a machine that can treat all different type of goods, so bio waste, plastics, and paper. But at the end of the story, we decided to not do that, because the investment was a huge investment, only because we do not know if it's possible from the legal point of view doing that. When we will know it, of course, if it's possible, we will do this investment, because if it's the way in which the company would like to go, a European project can help, but if you would like to do a good job, you have to invest something in terms of people, in terms of payroll of people that are working in the project, but also in terms of small investment. For example, the moving from the today paper to the digital one, it will cost, and it's not in the project. Our partner will do the first analysis, but at the end of the story we have to pay to have somebody that some technician that create this I don't know how do you say platform. So maybe that for I can say that for Costa we would like to do some maybe smaller project, but very tangible one, because otherwise it's not part of our business to do such project. No, our business is selling cruises, even if somebody sometimes but due to the fact that it is not part of our business, if we decided to invest in it, we have to do at our best. I don't know if I answered to you. So it would cost a lot of money. Grazie. Grazie per la caramella, stavo morendo, madonna. Ne ho fatto velocissimo, quanto ho messo? No, erano i miei termini, ma assolutamente nel generale. Non ho mai un problema con il tempo. Oh, ragazzi, ma è buonissima questa caramella. Puoi provare quale cosa? No, grazie. Non è neanche mia.
Vi ricordo di filmare il registro prima di uscire.